All right, so yesterday we did fractions, decimals, and then a little bit with percentages at the end, increasing by a percent, decreasing by a percent. Today we're going to do the other three little mini topics all together here. Rounding correctly, because that's going to apply to almost every single problem that we see this year. Using negatives, so just regular calculations with negative integers, and then combining like terms is what we're going to talk about. Okay. All right, so we are going to start with rounding vocabulary. So let's say you have a number and you want to round to a certain decimal place. That certain decimal place is going to have a word associated with it. So, like, for example, if I'm looking after my decimal place, what's the first decimal place called? Tenths, hundredths, thousands, you know the next one, 10,000. 100,000. And I think we have a little, oops, maybe we'll find out. Oh, I think that can go away. Maybe. Delete. No. It's not working. There it goes. I'll just drag it away. There are your terms. Tens, hundreds, thousands, 10,000s, 100,000s. If you don't know those, you need to make sure you write them down. What about if I go the other way before the decimal place? What's this last zero called? The ones, tens, hundreds, thousands. So the big difference is if it has a TH at the end of it, let me again see if I can move that away. There. If it has a TH at the end of it, it's going to be something after the decimal place. If it does not have a TH, it's going to be something before the decimal place. So I can sometimes get confusing with tens and tenths, hundreds and hundredths, et cetera, et cetera. When you are rounding, let's say I want to round to the, I don't know, it's highlighted, so the hundredth place here. You look at the decimal place that is after it. So I would look at the 3. If the number is 5 or larger, we're going to round up. If the number is smaller than 5, you're going to keep it the same. You're going to round down. So here it is 3, smaller than 5. So I would just cut it off and say it's 0.12. Let's say that 3 was actually a 7. Again, those last 3 decimal places would disappear, but that 2 would round up and become a 3. Okay, so you're changing the digit in the place where you are rounding to, but the digit after it is what determines what happens to it, whether it stays the same, rounds down, or rounds up. All right, so go ahead and put this number in your notes. 24557.0634991. If you're wondering where this number came from, what it represents absolutely nothing. It's just the numbers I hit in my keyboard very quickly when I made this lesson. Okay. And we are going to round this number to a few different decimal places. We're going to practice. We're going to do this slide together, and then on the next slide, you guys are going to try it on your own. Okay. All right. So let's say I want to round to the hundredth place. What digit currently is in the hundredth place? The 6. Okay, so if I want to round to the hundredths, I'm going to look at the 3, the number after it. Does that 3 tell me to round up or down? It tells me to round down, so essentially my number is going to get cut off after that 6. It's going to look like 2457.06. Good. Okay. If I want to round to the tens place, what number is after the tens? 7. So that's the number that's going to determine whether I round up or down. The 7 tells me to round up. So it would round to what number? 2, 4, 6. What? Is 246 make sense for that number? We're missing something here. We're missing a 0. It actually rounds up to 60. And then technically everything after it is also a 0, right? We could write 0.0000000. We just usually don't do that. But if you are missing a digit before the decimal place, you want to include that 0. Thousands. What number is in the thousands place? 2 is in the thousands place. Remember, it doesn't have a TH at the end of it. It's happening before the decimal. Okay, so I look at the 4 after it. Do I round up or down? Well, it's going to stay the same. I'm rounding down. Okay, so it's going to round to what? 2, and then everything after it's a 0. 0, 0, 0, point. 0, 0, 0, 0, 0. I'll write that. Tenths. What number is in the tenths place? 0. So I look at the 6 that's after it. Does the 6 tell me to round up or down? Up. So what's that number going to look like? 2, 4, 5, 7. Point. The 0 becomes a 1. We round up. Everything after it is a 0. What number's in the ones place? 7. The number after it is a 0. Do I round up or down? Down, which means my number is going to stay the same. 2, 4, 5, 7. And then again, everything after that is a 0. So you could say 0.0 if you want. 100 thousandths. What number is in the 100 thousandths place?
1.
Close.
29.
It's not. Yep. So we've got this one's you almost gonna have to count it. Tenths, hundredths, thousandths, 10,000s, 100,000. So it's the 9 that we're looking at. The 1 after it tells me to do what? Round down. Keep the number the same. So that would round to 2, 4, 5, 7, 0, 6, 3, 4, 9. Just pretty much take that 1. Okay. Any questions? All right, I'm going to give you guys a few minutes. Try this one with your partner. Write the number down and round appropriately. Rounding is not going to be something that we are learning throughout the year. It's something that is definitely a review topic, but when you're doing your algebra steps, if you are rounding incorrectly, you're going to be losing points for doing so. You want to make sure whatever answers you're writing down are accurate, which is a really important skill to practice. Okay? All right. Moving on. Next, we're going to talk about operations with negative numbers. The pre-test that you guys took on, what day did we do that? Tuesday. There was a problem where it was 5 minus 28. What's the correct answer to that? 5 minus 28. Correct answer is negative 23. I had about 15 to 20 people in both of my classes put down positive 23 as an answer. Can you switch the order when you are doing subtraction? You cannot. Okay, so yes, you end up with a negative number, which is not quite as pretty, but it's something that we're going to have to deal with. So you want to make sure you're not just dropping off negatives if a negative answer occurs. When you are adding with negative numbers and positive numbers, you're just moving, think of it as left and right on a number line. You start at 0, so let's say I want to add 7, or start with 7. I'm going to go 7 to the right, and then I want to add on negative 9. The negative value tells me I'm moving to the left. So if I go 7 to the right and 9 to the left, where do I end up at? Negative 2. Okay, so that's a good way to think about these. Maybe, there we go. So if you have negative 12 plus 19, think of it as moving 12 to the left and 19 to the right. Where would that take you? It would take you to positive 7. Okay. If I have negative 8 and negative 3, we would move 8 to the left and then another 3 to the left. Where do I end up? Negative 11. Good. Okay, and then of course we can do it with bigger numbers. If I have 80 and negative 34, a little bit tougher, right? 80 to the right and then 34 to the left. 46. Positive or negative? Positive 46. Good. Is that a good way to think about it? Yeah, so a positive plus a positive is always going to be positive. A negative plus a negative is always going to be negative. And then if you have a positive and a negative, it could go either way, right? Depending on which number is bigger. All right. Let's say we're subtracting with negative numbers. We're going to change it to an addition and then move left and right on the number line. You may remember from previous math classes, if you have minus a negative, like we see in this first one, that's the same as what? Plus a positive? Did your math teacher say that quite a bit? Minus a negative plus a positive? Okay, so instead of plus a positive, we just change it in high school to plus. This is the same as 7 plus 4, which means I go 7 to the right, and then another 4 to the right, which takes me to my answer is positive 11. Negative 16 minus negative 1. Again, I see minus a negative, so we change it to plus. Okay, and now think about our number line. We'd start at 0. We'd go 16 to the left and 1 to the right. Where does that take me? Negative 15 is correct. Okay. If you have subtraction, instead of subtraction, you can change it to plus a negative. So instead of negative 5 minus 10, I can change it to negative 5 plus negative 10. And then we can just think about moving left and right. So this is left and then more left. What am I going to get? What am I going to end up at? 5 to the left and another 10 to the left. Go ahead. Negative 15. So we're going negative and then more negative. And then same thing's going to happen with that last one, right? It's negative 30 and then really plus another negative 34. Where does that take me to? What's my answer going to be? Negative 64 is correct. Questions? Adding and subtracting negatives. Really just moving around on a number line. Nothing crazy, right? Okay. You all know you can put negatives in the calculator. You too. Just make sure if it's a negative, you don't put a subtraction in its place or vice versa. That can sometimes give you a little error on the calculator. Multiplying and dividing. There are rules that work every single time for these ones. And you guys don't have to write the words here. If you just want to write, like, instead of positive times positive, put the plus sign like this in your notes. Might be a little shorthand for that. If you have a positive number times a positive number, the answer is always positive. If you have a negative times a negative, the answer is always positive. Negatives, when they multiply, are going to cancel. A negative times a positive will give me a negative. And a positive times a negative will give me negative. Okay, so if you have one negative, your answer is going to be negative. If you have two negatives, they're going to cancel each other out and you get a positive answer when you're multiplying. Dividing, the rules are the same. Positive divided by a positive is positive. Negative divided by a negative is positive. And if you have one of each, you will get a negative answer. So again, multiplying and dividing with negatives, if you have two of them, will cancel each other out and give you a positive value. Any questions on this slide? All right. With your partners, try these. Okay. And I'm probably just going to come around and tell little groups to put answers up on the board. One of you two needs to put up negative 5 times. One of you two needs to put up negative 4 times. You guys are in charge of negative 24 and 5 times. Put your answer up here. You guys are in charge of negative 20. You guys are in charge of if I've given you one and you have the answer to it, you can start going up to the laptop and putting it on the board. You guys are going to be in charge of the work.
You're a failure. Yeah. Yeah. Yell harder. Try harder. All right. Like that. Good job. 0.35. Excuse me. Sorry.
I know there's a lot of buttons. We're going to take a whole day in like 2 weeks, and I'm just teaching it all buttons. If you hit second, which is the blue button, and then on. Hey, graphing calculator people, I'm thinking about it. If you don't know how to turn your graphing calculator off, I know some people have like weird ways to do that. Off. You know where the button is. We're going to hit second on. Second's like on the top. It's usually like a different color button, like yellow or blue or something like that. So hit second on. Turn it off. Okay, what do we think of the answers on the board? Yay? Nay? Anything we need to look at closer? There we go. That's good. You found it. Okay. Anything else we want to look at? That's just a 35 there, right? I don't need this little guy. Okay, these are good. Questions, comments, concerns? Okay. Last little thing that is in our lesson today. 2 more slides for you is combining like terms. This is actually one of the lessons that we're going to spend a lot of time with in chapter 1. But you have done this before, and there's some common mistakes that happen, so we're going to try to get on the front end with this a little bit. So when you are combining like terms, adding like terms is most of the time what you're doing with this. You are changing the coefficient, which means the number in front, but not the actual variable, okay? So anything that has the same variable is considered a set of like terms. For example, if I'm looking at this first line here, the first expression, I have a negative 2x and I have a 6x. Those are considered like terms because they have the exact same variable. I combine together the negative 2 and the 6. What is negative 2 plus 6? 4. And the variable stays the same, x. The plus 11, he's lonely. He doesn't have any buddies that are his like terms, so we're just going to bring him over. Plus 11, they are not like terms because they do not contain the same variable. This is as far as you could simplify this expression. So give me a pair of like terms in the second line here. Give me a pair of like terms. 9n and n. And technically, what number's in front of that n if I wanted to put a number there? 1. Okay, do I have any other like terms here? Other like terms? I have a negative 10. Now be careful with these. Remember, subtraction is a way of writing a negative. And negative 3. Okay, so if I have 1n and 9n, how many n's do I have? 10n. Remember, that variable doesn't change. If I have negative 10 and negative 3, negative 13. So you could write plus negative 13 here, or you could write just minus 13. Either one is fine. Okay, down at the bottom now. A few extra terms in this one. Give me a pair of like terms. Good. Good. And we say those are squared. So I have a 5a squared and a 7a squared. What else? Give me another set. Okay, negative 6a and 3a and 8a. I've got 3 of those that are all the same. And then finally my constants, my numbers without any variables. I have a negative 2 and a positive 7. Let me see if I can move this up a little bit more for you guys. No, maybe not. Is it a little bit better? Maybe? Okay, so my 5a squared and my 7a squared, if I put those together, what do I have? 12a squared. Okay, my negative 6a, 3a, and 8a. It's addition, so you can do it in any order you want. So 3 and 8 give me what? 11. And then a negative 6 gives me a positive 5. So plus 5a. And then finally, I have a negative 2 and a positive 7, which are going to give me what? Positive. And again, these cannot be combined together. They all have different variables, so this is as far as you would be able to simplify that expression. Okay? Last slide. I've got a mix here for you of addition and multiplication, which again, we'll talk a lot about this here, but just some common mistakes. 5x plus 6x. If I add them together, what do I get? Those are like terms. I get 11x. In the second line, I've changed it to multiplication. Okay, now multiplication, you do not have to have like terms to be able to combine them together. We are multiplying the numbers up front, the coefficients, and the variables. So if I have 5 times 6, I get 30. Does anybody know what x times x is? X squared. Yep. Okay, so multiplication, we do change the variable because we are multiplying. Okay, 3y plus 6x. Okay, it's addition, so I look for like terms. Do I have like terms? Do they have the exact same variable? No. So guess what? That's your answer. There's absolutely nothing you can do with that problem. There's no way to combine. Now, if I change it to a multiplication, I don't have to have like terms. I just start multiplying things together. So 3 times 6 gives me 18. X times y doesn't give me any sort of squared. All we do is pretty much just put them next to each other. XY or YX, something like that at the end. Second to last one, 3y squared and 6y squared. If I add them together, what do I get? I get 9. And then the variable doesn't change because I'm adding like terms, y squared. What about 3y squared times 6y squared? 18. Y. It's going to be y squared and y squared. Cubed is a third power. It's going to be a little bit bigger than that. 4. Yeah. That's great. We'll talk, again, a lot more about that later in the year. That was a tricky one. All right. And that is it for our lesson. Combining like terms and rounding and negatives. Any questions?
No.
Do you feel like this was a good little review for you before we jump into new stuff tomorrow? Speaking of tomorrow, so tomorrow we are starting chapter 1, section 1.1. All of the notes, remember, are on Polaris for you posted, the blank ones. So if you want to fill in the blank notes, you are welcome to print them out on your own, put them in a 3-ring binder, and you can just fill them in as we go. If not, you guys can just take a paper pencil like you've been doing the last couple days. Tomorrow night, you will have homework. It is that first worksheet on your calendar and the first worksheet that's loaded on Polaris. If you don't want homework over the weekend, you can do that worksheet tonight if you want. The worksheets will not be handed out to you because we are saving paper as a school. So the worksheet, you are going to be looking at the picture of it on Polaris if you're going to actually be paper pencil writing your solutions out. Okay? If you do not have access to it, I can send one to you or I can print one out to you if you do want it early. If you want it early today, let me know. If not tomorrow, for sure, I'll print one for you until you do have access. Okay? So tomorrow night's homework 1-1. You can get a head start on it if you want. I'll do the cell phone lotto so you guys can have your phones back. Let's see.